21. Great, we're here with Team 21. We're at UTDesign. First question, can you tell us names in your majors and your project title?
My name is Richardson. My teammates are Jared Vaughn, Philip Needvant, and Katie Looper. I am an electrical engineering major. Jared and Katie are also electrical engineering majors, and Philip is a computer engineering major, and our project title is A Better Breast Pump.
Please tell us a little bit about your project.
We were inspired by an MIT hackathon that took place last year that tasked its attendees to come up with ideas about how to improve the breast pump. And so we were inspired by some of those ideas, and we decided that a way we could improve the breast pump was by adding an Internet of Things capability while also addressing some of the more common concerns like portability and noise. So what we did is we added a sensor to the breast pump that would measure the volume of milk expressed, and then using a TI Launchpad with a Wi-Fi booster, it transmitted that sensor data to a website that ultimately users can log into to look at their milk expression over time. Also, to address portability issues, we use longer-lasting 3.7 volts lithium polymer batteries to get 20 hours worth of use, which is much more than breast pumps that we were looking at last semester. And then we also used a quiet 5 volt DC motor that we then compartmentalized into an enclosure and surrounded by sound damping foam as a way of improving the sound as well, the noise control.
Please tell us about each team member's contributions to the project.
So this semester we really focused on improving our prototype. So Philip worked on a PCB, taking all of our components and then having a board milled and then soldering those components onto the board so that we could have a professional looking board that would go on top of our launchpad. So this is just a copy of the PCB that Philip made. And I personally worked on designing the 3D enclosure. So I just made a 3D model in SolidWorks and then had it 3D printed. The enclosure is right here. Katie worked on the website. So she just made sure that the website could live update by adding some Ajax. And then also she used Twitter Bootstrap to kind of create a framework for the website as well. So we should just improve the website capabilities over this semester.
Alright, can you show us where your working prototype is and how it works?
Sure. So our working prototype is right here. So we start with the TI Launchpad. From the Launchpad, we power a motor, and we also have a sensor off the Launchpad that transmits the data to a Wi-Fi booster. A lot of components are needed for the motor and for the sensor. So those components are here. We also have some LED lights to indicate whether the motor is on or off and whether it's transmitting data. Those components are in the back of the prototype over here. So here you can see where the LEDs are. This is the on and off switch, and then the start button for the motor. And this is the connection for the sensor as well. We have the motor in this front compartment. Here's our motor, and we're using a cap from a store-bought pump. We designed our own cap. Essentially the way the motor works is that you have a DC pump that has a piston on it, and the piston goes in and out of a dome, and that creates the vacuum. But the dome that we created didn't have the pressure we wanted, so we had to use a store-bought cap just to make sure we were getting the pressure we wanted. So we used a graduated cylinder just so we could use our variable resistance sensor tape to get the volume measurements. And so this is the graduated cylinder that we're using. And as you can see, the breast would go here. For our testing, we used a bottle. which is here. So you would just put the bottle here and then turn on the motor and then start the motor, and then the liquid would start to be expressed, and then it would come down into this cylinder, and then you would stop pumping by pressing the green button again, and then at that point the data would be transmitted wirelessly to our website. Which you can see an example of here. This is the website, and ideally we'd have user logins so each person would be able to access their own personal page, but this is just an example of just the general features of the website and what it would be.
Is there something like this out in the market?
Well, there are, I think there's a growing interest in making breast pumps more convenient for women, and we've seen a lot of products where breast pumps are trying to address issues of noise and portability. Something we haven't seen, though, is a breast pump that can automatically transmit pumping statistics to the web. We've seen some applications where you can enter that data manually, but nothing where you can do it automatically.
How is your prototype better than what's out there in the market?
Sure. Well, I think our prototype is better than what's out there on the market because of the added features that we created, and also the improved battery life. So it's better because you have the Internet of Things capabilities, and also because it can operate for a longer period of time than another breast pump. So it's more convenient.
How is this prototype different from the UTDesign 1 phase?
Sure. So this prototype is different in a couple of ways. First of all, the enclosure is different. Originally we were using just a laser cut acrylic enclosure, so it was a little bigger, a little clunkier. It's different also because we originally had a proto board with loose wires in the enclosure, and so this semester we designed a PCB just to make it more compact and clean. It's also different because our website is a little bit fancier. Last semester we just had a table on a web page. It wasn't live updating, so we have to refresh it. This semester we've added live updating. We've also added a few more features to the website just to make it more user-friendly.
Last question. What is the next step to make your project marketable?
Well, I think something we have to go through is the FDA approval process. That can take years and cost a lot of money. So that would be an obvious step. But I think also a step that we hope to inspire other companies to take is that we really need to address more mechanical issues that were really beyond our scope as electrical engineers that I think could make that could really make the project could make the project more marketable to what we're looking for a more